Okay, in this video I'm going to go over the basics of Boolean functions and also give you a couple of examples of assigning English language phrases to Boolean variables. So just as a quick review here, you can see I've set up a lot here already. A Boolean function, f, is one that maps the set of length n bit strings to a single Boolean output variable, meaning that we're going to take as input strings of bits, zeros and ones, n zeros and ones in a row in a list, and as output we get either a single zero or a single one. Okay, the inputs and the outputs when we have are called Boolean variables. Okay, so a Boolean variable takes on a value either 0 or 1, variously interpreted as being false and true, no or yes, valid, invalid, etc. Okay? In the case n equals 2, our bit strings are of length 2, and the domain then is the set of all possible bit strings of length 2, and you can see there are 4 of them here. And so the size of the domain as a set is 2 to the n or 4, using the counting principle as described in an earlier video. In the case where n equals 3, we write the function as a function of p, q, and r, where each of p and q and r is now an input Boolean variable, and the total number of possible inputs is 8. When you add one more Boolean variable, you double the number that you had from the previous set. Okay? And so in this domain here, the first value in any of these pairs is the value of p, and the second value is the value of q. So in this one here, the second one, 0, 1, p is equal to 0 and q is equal to 1 is the interpretation there. So again, p and q and r are Boolean variables. They can take on a value either 0 or 1. And the basic Boolean functions we've had so far are p and q, p or q, not p, or what's called the exclusive or, XOR, which means p or q but not both. And instead of writing them out like this as a function f, what we do is f of p and q, what we do is we put p and q in between the symbols for and, or, and we put the not symbol out in front of the Boolean variable to negate it, and we put this plus sign with a circle around it for the XOR function. Okay, so that's a quick review of where we're at, and let me just give a couple of examples then of the interpretation of the and the or and the not. Okay, so if I let p be the statement 3 is greater than 0, and I let the q be the statement 2 is greater than 0, and r be the statement 2 is less than 0, then you can see clearly from your mathematics that p and q are both true, and so they would both have a value 1, whereas r is false, and so it would have a value of 0. Okay, and so we can use the true-false interpretation of the Boolean variables to interpret statements like this. Okay. And what we're going to do then is we're going to make a compound statement, and we're going to say something like, let's use the variable s. And I'm going to say s is p and q. Let's say that s is p and q. Then s would be the statement 3 is greater than 0 and 2 is greater than 0. And you can tell that that's a true statement because both p and q are true. Whereas if I made t be p and r, then t would be the statement 3 is greater than 0 and 2 is less than 0. And if I'm claiming 3 is greater than 0 and 2 is less than 0, then there's something wrong there. 2 is not less than 0, and so the and statement can't be true, and so t is a false statement, whereas s is a true statement. Okay, and the same thing goes for or and not. Not p is the statement that it is not the case that 3 is greater than 0, And in mathematical terms, we would write 3 is less than or equal to 0 is the negation of that statement mathematically. Okay, to continue on with some examples like those in the homework, what I've done on this page is I've set up a couple of Boolean variables, P and Q. P is the statement that this song is popular. Q is the statement that I like this song. And I'm going to go ahead and define 3 more statements based on these first 2. And what I'm going to do then is I'm going to write S and T and U in terms of P and Q using the notation. Okay? So the statement S is, this song is popular, but I don't like it. And it doesn't look like an and statement, but it is. And when you use the word but in a statement like this, it means that we're saying both are true. You know, it might be saying a little bit more than just this song is popular and I don't like it, but it really means basically the same thing. Okay? And so the statement S would be equivalent to or equal to, let's see, it says this song is popular and I don't like it, so this would be P and Q. T says either I like this song or it is popular, but not both. And you can recognize this as the XOR. Now I hope you don't mind if I make some diagonal equal signs here. And I'm going to say that this is, let's see, it's I like the song and it is popular. Okay, so that's P and Q. Or that's Q and P. So this is Q XORed with P. Okay? Finally, on the third one here, I like this song and it is popular. And, oh, just a second. I made a mistake back here. Watch out. This one says I don't like it. That is the opposite of Q. Sorry about that. It's easy to make mistakes. You got to check your work in this class. And so I'm going to fix this up and say P and not Q. Okay, sorry about that. You may have been wondering, and hopefully you would have spoken out in class had I done that in class. I like this song and it is popular. Now here I'm putting the equal sign right below the previous one, and that means that I'm continuing the equal signs. Okay, here I can continue an equal sign going across. Here I continued it going diagonally just for convenience. Here I'm continuing it like this. I like this song is a Q, and it is popular is a P. Okay? And so those are some examples of taking, and of course the mistake I made is that I didn't properly account for the fact that the statement here was actually the opposite of the one that I had up above. That's the easiest mistake to make when you're making these translations. And try to remember to always check for that. And the technique here, more important than getting it right the first time, is to check your work over, go back, read it, think about it, make sure that it works, okay? You will find that I do make mistakes. And as I say, it's not as important to get it right the first time as it is to look back over it, think about it, and to fix it when you do find a mistake, and to always go back and look back over it. So it's very easy to make mistakes. I don't expect you to do everything right the first time. You shouldn't expect yourself to, but you should get into a habit of going back and double checking all of your work in a math class. Okay, so I'll leave it at that. Hope this helps for the homework problems.